Now we want to look at how to transform your displacement diagram into an actual CAM drawing. And we're going to do three things, three separate videos. In this one, we'll look at how to draw the CAM profile and working drawing, mostly in general, a little bit of detail about our assignment. In the next PowerPoint and video, we'll look at our assignment specifically. What exactly do you do? And then in a third video, we will look at what can you do in CAD. So we'll start out with thinking about how to draw the CAM profile. And you'll start with the center line of your shaft, because that's the point around which your CAM rotates. And you'll start with one follower in the what you call the 0 position. Where is it starting from? Now, there are two kinds of circles, and you need to be careful you use the right one. This is the one our book gives us, and we don't want this one. The base circle, which he gives us, is this imaginary circle that is tangent to the bottom of the follower when it's at its lowest position. But that's not what we need when we lay out our drawing. What we need is a bigger circle that goes through the center line of the follower, and it's called the prime circle. So backing up, here's the base circle, the smaller one, tangent to the follower. You can ignore that. Here's the prime circle, a little bit bigger. It goes through the center line of the follower, and this is the one you will use for drawing your CAM. So here's a drawing with a lot of stuff on it, with that prime circle going through the center of the follower when it is at its lowest position, which would be 0 on your displacement diagram. Okay, now somehow we have to get from this graph to the lumps on our follower. And here's the thing, this CAM is going to be rotating, and so at each degree of rotation, that follower is going to be at a different position. So how are we going to accommodate that? You could make a whole bunch of copies of this CAM rotated at a different position with the follower at a different height, but that would be ridiculous and not helpful. So what we do, the trick for CAM designers, is we leave the CAM where it is, and we draw a bunch of phantom line followers temporarily around the CAM. Here's the thing. The CAM rotates in one direction, like let's say the CAM is rotating counterclockwise. That means the followers will be essentially marching around the outside in a clockwise direction. So here I've tried to illustrate that with an arrow. If the CAM is rotating clockwise, you rotate your, if your CAM is rotating counterclockwise, you'll locate your followers in a clockwise direction. So when the CAM rotates 30 degrees, there's a follower at 30 degrees in the clockwise direction. If that bugs you, just ignore it, and we'll just look at specifically what do we do in our drawing. Okay, now let's get to the displacement diagram. We have our prime circle here that goes through the center of that follower. And as that follower moves up and down, which you graphed on your displacement diagram, it moves farther out away from that prime circle. So what you do is you go to your, let's say you're thinking about what happens when the CAM has rotated 30 degrees. You go to your displacement diagram at the 30-degree line, and you measure that height. And that's how far out beyond the prime circle this next position of your follower will sit. And for those of you who can see color, I have color-coded these lines, these heights from this displacement diagram. So for example, at 60 degrees, there's that height. It's a little short height at B at 60 degrees. There's that little short height. That's how far out away from the prime circle the follower is there. Moving along our graph, when we get to 180 for this particular cam, there's a long distance. That's the height under our curve. And so that's a long distance from the prime circle out 180 degrees to where the center of our follower is sitting. If this is bugging you, just let this first wave wash over you and we'll come back and pick it up again. This isn't our first time we'll think about this. And as you lay out these distances, that follower, our follower is, I think, a 3/4 of an inch in diameter circle. That follower is, the center of the follower is sitting at the end point of that radial line. And then we come along and draw the actual cam. And how do we do that? We go tangent, 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 tangent with a spline or a polyline. These followers are tangent to the surface of the cam, aren't they? Every place the cam is, there's a follower tangent to it. So we mimic that by using I recommend a spline, tangent to each of those followers. Now for dimensioning your cam drawing, this is a working drawing, which means someone in the machine shop will be using this drawing to make the cam. There are two methods for dimensioning a cam. Here's the one we're not going to use, but just be aware you could do that. You could use polar dimensions with an angle dimension every so often, and then a radial distance at that angle. That's, in my opinion, hard to read, and it's going to make a really crowded cam drawing. So we're not going to use that. We're going to use this other method with a table. And in our table, we'll write a heading in the table for each angle that we're recording, and then we'll give the distance from the center of the cam out to the center of the follower. Now, the displacement diagram is a design tool. The shop does not need to know about that. In fact, it'll just confuse them if you send it to them. So this is your tool for figuring out the cam. The table is the tool used by the shop. They will have some kind of programmable machine, some kind of CNC machine, where they can input these numbers into their program and it will cut the cam. So this is the drawing that they want to see. They don't want the displacement diagram. This is just a thinking tool for you. They do want your drawing with this table that they will be able to input into their programmable machinery. So now, this is a regular working drawing with dimensions. You'll need to give them a side view because you need to show how thick is this thing, and then how far does the hub stick out, and what diameter is it, and what is the radius where the hub joins the plate. And you'll need dimensions for the keyway using our good old standard keyway dimensioning method that we've been learning this term. So from the bottom of the hole to the top of the keyway with its tolerances, and then the thicknesses with the width tolerance for the keyway. Now, this drawing is an example from our book, so it has different numbers than we will use in our drawing. And you'll show the follower once with a phantom line. This is what your drawing will look like. I don't have the numbers in here yet, but this is the shape that you should come up with. Here's the side view, here's the front view. You'll have some notes here at the bottom. Now, to enable your machinist to set up their machine, here's what you do. On your drawing, on the front view, you make an angle dimension, but you just write A degrees, because this angle dimension is going to vary all the way around the cam. So you write A degrees, and then in the top line of your table, you say angular displacement from 0 is A degrees, and then you'll be listing the different degrees, 30, 60, 90, so forth. Then you give a dimension using the align dimension command from the center of the cam to the center of that first follower, and just label that R, because that distance is going to vary with every position around the cam. So you just label it R, and then in the table you say R is the radial displacement from the center of the shaft, and you are going to give your machinist the numbers that they'll put into their machine. Remember how this cam that we're drawing has dwell in 2 places. Well, what happens with dwell? That's where the follower does not move, it does not go up and down. And how do we get that to happen? We have a circular shape, so the radius does not change in here. It's the same radius of circle from here to here. That makes the follower just sit in one spot. It dwells. So that means in these 2 places on your cam, you'll need to draw circular arcs, not lumpy things. When you are finished, you will have 4 separate splines and arcs, 4 separate lines in your drawing. If you try to make it all one connected polyline or spline, it won't work, sadly, because you really need a truly circular arc down here at what I've labeled 2, and a truly circular arc at what I've labeled 4, and then you'll have a lumpy line going around this right side, and another lumpy line going around the left side. So here is approximately what your cam will look like. You'll have numbers in here, of course, and the keyway will need depth tolerance and width tolerance. Notice you also have a diameter for the size of the hole in there, and a diameter for the size of the hub, a radius where the hub joins the plate, the thickness of the plate, and the thickness of the hub. Oh, and the size of the follower, which is 3/4 of an inch in diameter. Whew! So now we'll go look at how to do this in your particular drawing.